and the basics. Okay, who can tell me parallelogram law of forces? Can you? Very good. Ben? Yes. Okay, in a tail to tail fashion. Okay, with an angle theta. Good. Maybe you're not able to express, right? Next class you'll have to be in a situation to express also. Okay, and is it getting recorded? Are you sure it's getting recorded? By the end of the class, you'll have to take a guarantee for this one, right? Okay, so now just listen here. In today's class, we'll just get into another concept, and this is going to be called as moment of a force, right? So just make a point, make a note. The heading is called as moment of a force. Moment of a force. Analytical method. Didn't I give you the formula? Okay, so now just listen here. Maybe I think one topic I missed it yesterday. See, if something is getting missed, you can just have reference of your note and you can give me a reminder. Do you understand? So now listen here. In case if it is going to be a force, all of you listen here, I'll just give a base again, right? A force, it is going to be represented by means of a straight line, right? And an arrowhead also. I'll put a blue. Okay, so now just listen here. In case if it is going to be a force, it is going to be represented by means of a straight line and an arrowhead. Do you understand? So the length of the line is going to give what here? Magnitude. Very good. And this direction, maybe this arrow, it is going to give the direction. Do you understand? So now just listen here. In case if two forces are going to be like this, say let us call this force as equivalent to say some P and this force as equivalent to say some Q. Do you understand? And let the angle of tilt in between the forces be equivalent to say some theta. Do you understand? So now listen here. So here to find out the resultant, I said that it cannot be equivalent to P plus Q or Q plus P or Q minus P or P minus Q. All is wrong because say this force it is going to act in the horizontal direction and this it is going to be acting in the inclined direction, right? So you cannot say that the resultant here is going to be equivalent to P plus Q or P minus Q. It's wrong. So there are three methods I said. One is going to be the triangle law, which I taught you in yesterday's class. Second one, it is going to be parallelogram law of forces. That is also taught and you answered questions in connection with that. And the third one, it is going to be the analytical method, right? Analytical method in the sense it is going to be more involved with some formulas. Do you understand? So the formula to find out the resultant here is R is equivalent to root of P square plus Q square plus 2PQ into cos of theta. Do you remember this formula in maths? Yes or no? The same formula, right? What has been studied maybe in schools, we are going to just have it here again. Is it clear? Triangle law and parallelogram law is new, and this formula is quite known to you, right? If you've forgotten, you can just make a note of this one because this will be of use later. And problems in connection with this is not much asked in the university exam. So problems in this, I'll do it a little bit later. I'll just cover the important topics first, and then maybe topics which is not that important. And problems in this is very simple also, right? So now we just make a note. The third heading, you can just write it as analytical method, analytical method, analytical method. And you keep a full stop. And then below that, you can just write the resultant of two concurrent forces, the resultant of two concurrent forces, the resultant of two concurrent forces, the resultant of two concurrent forces can also be obtained, can also be obtained, can also be obtained, can also be obtained from the formula, from the formula capital R is equal to, from the formula capital R is equal to root of P square plus Q square, a full root. And what is marked on the board, you can just make a note. And below that, you just write wherein P and Q, a little bit fast because I'll have to do a lot of things. Below that, you can just write where P and Q are the two concurrent forces, where capital P and capital Q, where capital P and capital Q are the two concurrent forces, and theta is the angle of tilt, and theta is the angle of tilt, and theta is the angle of tilt between these two forces, and theta is the angle of tilt between these two forces, and theta is the angle of tilt between these two forces. Is that clear to you? Okay. So now the next concept, you can just take it as moment of a force. Moment of a force. Moment of a force. Okay, so now just get me a long scale. Who has got a long scale in the class? Yes, please pass it here. Okay, so now all of you listen here. Say for example, if I'm just holding the scale here, right? See now listen here, now I'm slowly getting into the engineering aspects, right? So you'll have to understand stuff better. So if I'm holding the scale here, right? and if I'm just applying a load here, there is no possibility for the scale to bend. Do you agree to it? See, I'm just holding the scale here itself, and if I'm just applying a vertical load like this, the scale is not going to bend. Do you understand? But if I'm just having a fold here at a distance, and if I'm just going to apply a load here, what happens to the scale? It is going to bend, right? See, now I'll tell you one thing. Priorly, right? If the pressure or maybe the load what I'm applying is going to be the same, right? And if the fixture is going to be here, right? The scale is not going to bend, right? But if I'm just having the fixture at a distance, and if I'm just going to apply the same load which was applied before, now you can just see that the scale is going to bend. Do you understand? So this distance, it comes into picture, right? And from here you'll have to know one concept called as the moment. Do you understand? So now if you listen here, say now, if I'm just having a point, right? Let me call the point as equivalent to say some A. Do you understand? And let me take some small distance from here. And let the distance from this particular point towards the right be equivalent to small x, right? So if I'm just applying a load here, right? Let the value of the load be equivalent to capital P, right? This load, right? It tends to bend, say this particular point, right? Or if at all, maybe you're having a beam or a horizontal member here, this load, it will try to bend this beam or say the horizontal member in this particular direction, right? So this concept is going to be involved with your moment, right? So moment in the sense, it is given as equivalent to force into perpendicular distance. So if you want to calculate moment, moment is going to be represented by the letter capital M, and if you're going to calculate that with respect to this particular point, have it in the suffix, and that is going to be equivalent to force or load into distance. You understand? So what is the load here? It is going to be capital P, and what is the distance from here to here? It is going to be x. So moment, it is given as equivalent to P into x, right? And the effect of moment is that it will try to bend, say, beams or horizontal members. Do you understand this? Okay. So now if you listen here, if there is a moment like this, which is going to be clockwise, you'll have to understand what is meant by clockwise and anti-clockwise. So if I just keep my finger here, right, and rotate this P in the downward direction, right, not exactly in the downward direction. If I just rotate it like this, it is going to be clockwise, right? So if it is going to be clockwise like this, it is given a positive sign. Is it clear? Okay, so now let me take up another point, and let me call this particular point as O. Do you understand? And let me take a small distance towards the right of this one, and let the distance be equivalent to x, and let me have a load in this particular direction, and let the value of the load be equivalent to capital P. Do you understand? So now what will be the moment of this particular force with respect to this point? Can you just say? It is moment is represented by capital M. Good, right? And as you're going to calculate that with respect to this particular point, have it in the suffix. So it goes as M suffix O, right? And it is going to be equivalent to, what is the basic definition of moment? Load or force into perpendicular distance, right? So what is the load here? It is going to be P. And what is the perpendicular distance? Perpendicular distance in the sense, it is going to be maybe 90 degree here. Do you understand? So what is the perpendicular distance between this load and this point? It is going to be x, right? So what will be the moment value here? Very good. It is going to be P into x, right? So now if you listen here, there is a difference between this and this, right? So what is the difference? Can you just say? Yes, say now, if you're going to rotate this particular force with respect to this point, this is going to be clockwise. Do you understand? But if you're going to rotate this capital P with respect to this particular point, it is going to be anti-clockwise. Do you understand? If you are just a little bit, say, confused about this rotation, what you do is, you just assume this to be the compass point, right? And this to be the pencil point. And if you're going to draw an arc, right? Maybe in this particular direction, it is going to be anti-clockwise. Is it clear? And if you keep your compass point here and pencil point here, right? And if you're going to draw an arc, right? That is going to be clockwise. So if it is going to be clockwise moments like this, it is given a positive sign. And if it is going to be anti-clockwise moments like this, you'll have to give a negative sign like this. Is it clear? Okay. So the next heading, you can just write this moments. See, this is very, very important for solving problems, not only this semester, but the next semester. This concept is very much important, right? So just make a note. You can just write this moment of a force. Moment of a force. And just make a copy of these two diagrams. Make a copy of these two diagrams. Moment, basically, it will try to bend a beam. Do you understand? Moments, it will try to bend horizontal structures and beams. And which is the sketch number as per our notes? Because later I'll take reference. Yes? Okay, you can just call this as 8A, right? And this you can call as 8B. And based on that, my notes will be added to you, given to you. Okay, so now I think you've copied the diagrams. Okay, so now we can just make a note. A little bit fast. have made a copy of the diagram? Okay. So now we can just write moment of a force with respect to a point. Moment of a force with respect to a point is defined as moment of a force with respect to a point. Moment of a force with respect to a point is defined as the force multiplied by is defined as the force multiplied by the perpendicular distance is defined as the force multiplied by the perpendicular distance between the line of action of the force multiplied by the perpendicular distance between the line of action of the force and the point about which the moment is calculated and the point about which the moment is calculated. Keep a full stop. And the next line you can just write, if moments are clockwise, if moments are between the force and the point about which, a little bit fast, right? And the point about which, what happened to your previous notes? No, you'll meet me later. No, all this it is not allowed in my class, right? And the point about which the moment is calculated. And the point about which the moment is calculated. Keep a full stop. And you can just write, if moments are clockwise, as shown in diagram 8a, if moments are clockwise, as shown in diagram 8a, it is given positive sign. If moments are clockwise, as shown in diagram 8a, it is given positive sign. If moments are clockwise, as shown in diagram 8a, it is given a positive sign. Full stop. And the next line you can just write, if the moments are anticlockwise, as shown in diagram 8b, if moments are anticlockwise, as shown in diagram 8b, if moments are anticlockwise, as shown in diagram 8b, it is given a negative sign. It is given a negative sign. If moments are anticlockwise, as shown in diagram 8b, it is given a negative sign. See, now listen here. You will definitely refer a lot of books, okay? And few to be foreign author books, right? So now just listen here. Do not get confused. Maybe I'm just giving you hints of your lateral studies also. So now few of your foreign authors, right, what they do is, for this, they're just going to give a negative sign. Sorry, for this one, they're just going to give a negative sign. That is, clockwise moments are given negative signs and anti-clockwise moments are given positive signs. It should be the reverse. In case if you're giving a negative sign for this one, this should be given a positive sign. But many of your Indian authors, it is going to follow this sign convention, wherein clockwise it is going to be positive and anti-clockwise, right, this it is going to be negative. And we'll be following only this, right? And in case if you're going to have any reference with foreign author books, you can just make a note. Maybe clockwise it will be negative and anti-clockwise it will be the other one. Do you understand? Have you got my point? So the next heading, you can just write it as Varignon theorem of moments. Varignon, V-A-R-I-G-N-O-N apostrophe S. V-A-R-I-G. I'll just give you the spell. V-A-R-I-G-N-O-N apostrophe S. Varignon's theorem. V-A. Okay. V-A-R-I-G-N-O-N apostrophe S. Varignon's theorem of moments. Varignon's theorem of moments. V-A-R-I-G-N-O-N apostrophe S. Varignon's theorem of moments. So I'm just having a plane, right? And here let me take few forces, right? So I'm just having one force and let the magnitude of the force be equivalent to F1 and let there be another force, right? And let this be equivalent to say some F2 and let there be another force, third one, right? and let this be equivalent to F3, right? So now in yesterday's class, I just told you what is meant by a resultant force, right? So what is meant by a resultant force? Can you just tell me? If two or more forces are converted into a single force, right? In such a way that the single force has the same effect as that of the number of forces, then that single force is going to be called as the resultant force, right? So totally in this particular diagram, how many forces you see here? Okay, and what are the forces? F1, F2, and F3, right? So all these forces, it can be converted into one single force, and that can be the resultant, right? And approximately, I'm plotting it here, right? See, maybe as numbers is not given, right, and details are not given, I'm just assuming, right, that the resultant is going to act here, and I'm just calling the resultant as equivalent to, say, some capital R. Do you understand? So now let me take up a point here and call the point as equivalent to O. Do you understand? So based on this diagram, right, I'll just write the equation in connection with Varignon theorem of moments, and you try to get the definition for this one, right? Okay, so now just listen here. So now let this perpendicular distance from here to here be equivalent to, say, some x1, and let this particular distance, right, perpendicular from here to here be equivalent to x2, and say this distance I am marking it, right? This perpendicular distance, it is going to be equivalent to x3, and the perpendicular distance from here to here, maybe you can just call it as equivalent to, say, capital X, right? So based on all these markings, right, Varignon theorem of moments is given as equivalent to, say, F1 into x1 plus F2 into x2 plus F3 into x3 is going to be equivalent to R into capital X. Okay, so now all of you just have a look at this equation, right, and just see the details in the diagram and connect it, right, and try to give the definition of what is meant by Varignon theorem of moments, right? If you're not able to get it, I'll definitely explain it to the class, right? Just have a look at the diagram, right, and the equation based on this one, right, and try to give me the explanation of Varignon theorem of moments. Who can do it? So you'll have to think, right, because always me teaching, okay, it is fine, but at last if you think, it is going to be an advantage for all of you all. I'm just having some forces, right? And I'm just marking some perpendicular distances of those forces with respect to point O, right? And based on that, I'm just getting an equation done here. So you'll have to connect this diagram with this equation and give the explanation. That is what is going to be the theorem of Varignon, right? So can you just give a try? Think a little bit. Even if it is going to be wrong, doesn't matter. I'll correct it for you. Yes? Is this the resultant force or is the resultant moment? Okay, this is going to be the resultant moment, right? The resultant moment must be equivalent to summation of moment of all. It's as simple as that, right? Very good. Maybe you just got maybe partially the answer correct, but at last I'll just give the explanation of this one. So now if you listen here, say maybe this is going to be a point O. See, I'll tell you one thing, the diagram, I don't know whether it's clear for students sitting at the back, but I'll just give an explanation on this, right? There is a point O, right? And this force is going to be F1, and the perpendicular distance between this particular force and this point is going to be equivalent to x1. Is that clear? Okay. Next one, I'm taking up another force here, right? And the perpendicular distance between this force and this point, it is going to be marked as equivalent to x2. Can you understand this? Okay. And thirdly, I'm just taking up another force, right? The force is going to be F3, and the perpendicular distance from here to here, it is going to be equivalent to x3. Do you understand? So all these three forces, it will be having a resultant force. So the resultant force, I'm just marking it as equivalent to capital R, and the distance, perpendicular distance of the resultant from this particular point O, I'm just calling it as equivalent to, say, capital X. Is it clear? So now let me take the moment of the first force with respect to this particular point. All of you listen here. If I'm taking the moment of the first force with respect to this point, what is moment defined as? Moment is defined as force into perpendicular distance, right? I taught you just now. Moment is given as equivalent to force into perpendicular distance, right? So if you want to take the moment of the first force with respect to this particular point, it is given as equivalent to, say, F1 into distance is going to be equivalent to x1. Do you understand? So what, and as it is going to be clockwise, I am just giving a positive sign here. Is it clear? Next one, if you want to take the moment of this particular force with respect to this point, say this again, it is going to be clockwise. Only see this, right? Don't see this force and this force. When I'm getting the moment of force 2, right? You just see only this one. So this force F2 on rotation with respect to this point, in which direction it will rotate? Clockwise. And what will be the moment of this force with respect to this point? F2 into x2. Very good, right? So moment of the second force, I'm just writing it here separately. That is going to be equivalent to F2 into x2. Are you clear with this? Okay. And third one, if you're going to take the moment of the third force with respect to this particular point, the force value is going to be equivalent to F3, and the distance from here to here it is going to be equivalent to X3, right? And this again on rotation with respect to this particular point, right? If you're getting confused with this one, assume your compass point here and pencil point here, right? And if you're going to draw an arc, it is going to be clockwise, and distance is going to be X3. So what will be the moment of the third force with respect to this point? F3 into X3, right? So just write it as equivalent to F3 into X3. So that is what is written here, right? And now, if you want to get the moment of the resultant, right? Maybe resultant, it is going to be again clockwise, right? And distance from here to here is going to be equivalent to X, right? So I am just writing the moment of the resultant as equivalent to R into capital X. Do you understand? And don't get confused as this, it is going to be a multiplication sign. No, it is going to be capital X, and this is going to be the multiplication sign in the middle. Do you understand? So I'm just having an equal to here, and I'm just adding it here and here. That is what is this equation, right? So now if you listen here, so now we can just define Varignon theorems based on this one, right? So just make a copy of this equation, and I'll give you the statement. And this theorem is usually asked for 2 marks. And if it is going to be asked for 6 marks, you'll have to give a detailed explanation, right? If it is going to be for 2 marks, you just have the diagram, right, and the equation, and just give a 2-line note. And in case if it is going to be asked for 6 marks, you'll have to explain the diagram in detail and then probably the equation in detail also. What you want to drink water? Yeah, do that. And I just want you guys to be seated in the front, right? I don't like it. What do you want? 2 marks, make it 2, right? And in case if it is asked for 6 marks, you'll have to explain the diagram, right? And then give a note on the formula. If it is going to be asked for 2 marks, you can just give a note on the formula alone. Is it clear? See, and maybe explaining the diagram is going to be easy, right? Maybe you can just extend it for a paragraph. You can just say that there are 3 forces acting on a plane, right? And these forces are going to be F1, F2, F3, acting at distances of x1, x2, x3 from a point O, right? Like that, you'll have to explain the diagram, and then maybe the formula also, if you just give a note on that with the equation, it will fetch you 6 marks. But if it is going to be for 2 marks, what you do is draw the diagram, get this equation, and just explain the equation in words, it will fetch you 2 marks. Okay, so have you made a copy of this one? Okay, and this is going to be which diagram? Tell me the number of this. It is going to be 9, right? It's going to be 9. Mark this as diagram 9. Okay, so now we can just write a note. Consider 3 forces. Consider 3 forces. Capital F1, comma F2. Consider 3 forces. Capital F1, F2, and F3. Acting at perpendicular distances of x1, x2, and x3. Acting at perpendicular distances of small x1, x2, and x3 from point O. From point O. Full stop. Then you can just write, let capital R be the resultant. You're rushing to do something. Let capital R be a bit clear. No, you're not done anything, right? Maybe where is the force? You're not marked the force. Don't you understand what I speak? Huh? Do not copy rubbish like this in my class. What's your name? Huh? See, I'll tell you one thing. Next time, maybe I'll make other students answer. I'll ask you questions. I'll record it in this, and if you're not going to answer, I'll play it for your parents. Do you understand? In my class, only one business is there, and you're going to listen, right? And you're going to learn. And what is this, man? Maybe I just made a different diagram, and you're not doing anything here. Just get to the front. Next time, I'll just tear the note, throw it on your face, chuck you out. You're going to be this. Go to the front and sit. The moment I'm just coming for a rounds at the back, you're pretending to copy. The diagram is not correct here. See, it is at last your work, right? I'm trying to help you. Try to understand that. Sit and do. Okay, so now what was the last point I said? Okay, let capital R be the resultant of all these three forces. Let capital R be the resultant of all these three forces. Let capital R be the resultant of all these forces. And let this be at a perpendicular distance. And let this be at a perpendicular distance of capital X. And let this be at a distance, at a perpendicular distance. And let this be at a perpendicular distance of capital X. And let this be at a perpendicular distance of capital X from point O. From point O. Keep a full stop. From point O. Keep a full stop. The next line you can just write the moment of the three forces, the moments of the three forces with respect to point O, the moments of these three forces with respect to point O is F1 into X1, comma, is F1 into X1, comma, F2 into X2 is F1 into X1, comma, F2 into X2 and F3 into X3 and F3 into X3. Keep a full stop. And then you can just write the moment of the resultant, with respect to this point O is capital R into X. The moment, sorry, what did I say? The moment, yes, the moment of the resultant with respect to this point is capital R into X. Based on this, the moment of the resultant with respect to this point O is capital R into X. It is here. Have you understood this concept? See, it is very simple, right? With respect to this particular point O, right? Moment of the resultant is R into perpendicular distance, that is R into capital X. That's all, right? Okay, so now we can just write, based on this, Varignon's theorem, based on this, Varignon theorem of moments is defined as Varignon, based on this, Varignon theorem of moments is defined as the sum of moments based on this, Varignon theorem of moments is defined as the sum of moments of a number of forces, is equal to the moment of the resultant. Okay, so now all of you listen here. In case if the question is going to be asked for 6 marks, you just give this theory, right? And in case if it is going to be a 2-mark statement that you'll have to have, how will you define this one? You simply say that you just draw this diagram. Listen here. For 2 marks, you just draw this diagram, right? Write this equation, and you just say that the sum of moments of a number of forces must be equivalent to the moment of the resultant. That's all, right? I just don't want stories for 2 marks, but it should be to the point. You understand? So if it is going to be 2 marks, I'll repeat it again. You just say that the sum of moments of a number of forces, right, must be equivalent to the moment of the resultant. That's all, right? With this equation and diagram, you'll be getting 2 marks. Because why I'm saying you this is because long questions, it will take a longer time for you to solve, right? Because you'll have to save a lot of time, and that can be done only in areas like this. Okay? Okay, so now I'll just ask you a few more questions in this. Okay, so now just listen here. I'm taking a point O here, and you want me to repeat it again? Varignon theorem of moments. Are you clear with it, all of you? Okay, so now just listen here. I'm having a force here, and let this force be equivalent to say some F1, and let the distance between this particular force and this particular point be equivalent to X. Do you understand? So now, what will be the moment of this particular force with respect to this particular point? That is my question. Okay, so now you are just saying that moment of this particular force with respect to this particular point, it is going to be represented as m suffix o, right? And it must be equivalent to how much? F1 into x. Okay, so how many of you say that this is going to be correct? And is there anyone telling that this is wrong? Yes, you're perfect, right? And why is it wrong? And you're also correct, right? Very good. What is the reason that this is going to be wrong? Yes, this is not the perpendicular distance. So if you listen here, this distance from here to here, it is not going to be perpendicular, right? Because this angle is not going to be equivalent to 90 degrees, okay? So what you'll have to do is just extend or draw the line of action of the force so that it will be a line like this. Do you understand? And now you can just mark the perpendicular distance from here to here, and if this is going to be equivalent to x1, then moment of this particular force with respect to point is going to be equivalent to f1 into x1, and this is wrong, and this is going to be correct. Have you understood? See, I told you, moment is defined as force into perpendicular distance. Very good, right? You just got the answer correct. Moment is defined as force into perpendicular distance. So if you're going to take this particular distance, the angle here is not 90 degrees, nor the angle here is not 90 degrees, right? This is going to be more than 90, and this is going to be less than 90. So this cannot be the perpendicular distance from here to here. But if you just extend the line of action of this particular force, you can just have an extension like this, and the perpendicular distance can be measured here. You understand? So now moment of this one is going to be equivalent to f1 into this distance x1 and not x. This is going to be wrong, the first equation, and this is going to be correct, right? So just make a mark of this also, because application of this one is going to be huge, right? Not alone in the semester, but also the next semester. Do not get confused. You also good, Darshini. You also got the right point. Good. And what's your name, man? Good. You need not come. Can I trust you? I'll be checking there. And take care of yourself also, right? That is also important for me. Okay, so now we can just take this question. Have you understood this, all of you? Okay. So now make a mark of this one. This is quite important for the university exam again. So now you just see, firstly I'm just doing all important stuff, right? And later on we'll focus on something which is not that important. So now we can just make a note of this. For the parallel force system shown, for the parallel force system shown in the diagram, for the parallel force system shown in the diagram, for the parallel force system shown in the diagram, determine the magnitude, determine the magnitude, determine the magnitude, direction, determine the magnitude, direction, and location of, and location of, and location of the resultant force, and location of the resultant force. And you can just make a copy of the sketch. Okay, so now just have a look at the board. So now what is the type of force system that you see here? Be specific. Yes, just have a look at the board and tell me what is the type of force system that you see here. Okay, it cannot be collinear because line of action of all the forces is going to be different, right? I'm not asking you that, I'm asking you what type of force system is. Very good, it is going to be, who said parallel? That's going to be correct, right? It is going to be unlike parallel force systems. And all of you listen here. Say now, if you just see this force and this force, both are going to be parallel, but directions are going to be different, right? Hey, listen here, all of you. Please listen, right? I'll be asking you questions specifically. Just make a note. So now here, this force and this force is going to be parallel, and directions are going to be different, right? And this too is going to be parallel to this, and similarly, all the forces are going to be parallel to each other, but directions are going to be different. Do you understand? So this is going to be a parallel force system, and as the directions are going to be different, it is going to be a unlike parallel force system. If the directions are going to be same, what type of force system is this one? Yes, it is going to be called as like parallel, but here this is going to be a unlike parallel force system. Do you understand? So now all of you listen here. So now firstly here you'll have to find out the resultant. The resultant you can just call it as equivalent to capital R. Just read the question and tell me what is it asking. Just all of you read the question fast. Yes, you'll have to find out firstly the resultant. Second one, the magnitude, and third one, the location of the same. Do you understand? So now if you want to find out the resultant, all of you listen here. In yesterday's class I just said that, say forces that are going to act on the right hand side, what sign you will give for this one? Positive or negative? Very good, it is going to be positive. And forces that is going to act towards the left, what sign you will have to give? Very good, it is going to be negative, right? So to find out the resultant here, it is very simple. You're just going to add and subtract and get the value done, right? So to find out the resultant, start from here, right? This 30 is going to be towards which direction? So what sign will you give for it? Very good, it is going to be positive, right? So you just give plus 30. Are you okay with this one? And just come down, there is 40, and this is as towards the left, you just give a negative sign, so it is going to be minus 40. And this one, what sign you'll give for this one? Very good, it is going to be minus 15. And for this one, excellent, right? Plus 25, and lastly, for this one, it is going to be minus 60. So what is the net result, tell me? Yes, it is going to be equivalent to? Yes, perfect, right? It is going to be equivalent to minus 60, and unit is going to be newtons. So with this, if the question is fetching you around 12 marks, you'll be getting 3 or 4, just for addition and subtraction, right? So just make a mark of this quick. And all of your notes, it is very, very neat. I'm very happy to see you write the notes like this. And of course, one or two are who are not maintaining the notes well, right? You'll have to be tuned and you'll have to maintain the way I say. Good. Okay, so now all of you listen here. So now what is the next part of the question asking you? Yes, fine. Direction and location of this one. So now all of you listen here. So now maybe there are totally how many forces in the system? 1, 2, 3, 4, 5. Do you understand? So what we'll do is, let us assume, right? This is an assumption. I am just assuming that the resultant is somewhere over here, right? It need not be exactly here. Once we just find out the final answer, we can just exactly locate this one, right? It is an assumption, and I'm just saying that let the resultant be somewhere over here, and let it be called as equivalent to capital R, and let the distance from here to here be equivalent to, say, capital X. Is that clear? So now if you listen here, now applying Varignon theorem of moments, you can just get the value of the resultant as well as where it is going to be located. Do you understand? So now as per Varignon theorem of moments, if you take moment about this particular point A for all the forces, what is the total moment you will get? Summation of moment about point A, we will take it up, right? So what is the equation you will get? Can you just tell? Give a try. If it is going to be wrong, it is all right, I'll correct you. Just give a try. I'm just telling you that you'll have to take moment of all the forces with respect to this particular point A and add it up together. Let it start from here. So what will be the moment of this 30 Newton with respect to this point? 30 into 1 will be here. See now, okay, I'll just do it. As it is the first problem, listen here, as it is the first problem, I'll just give a clear idea. Do you understand? So now if you listen here, when you're going to take the moment of all the forces, please listen, right? When you're going to take the moment of all the forces with respect to this particular point A, started from here, right? So now this 30 on rotation with respect to this particular point, it is going to be clockwise, right? Just be clear with this one. If you're not understanding this one, again, just assume that your compass point is here and pencil point is here, right? If you're going to draw an arc like this, it's going to be clockwise, and the perpendicular distance, right? Perpendicular distance from this particular force to this particular point is going to be 1 plus this 3 plus another 2 plus another 2 meter. Do you understand? So the moment of this one is going to be equivalent to, say, firstly, as it is going to be clockwise, and here you'll have to be clear with the sign convention. You just say that clockwise moments, you're going to give a positive sign, and anti-clockwise, what sign? It's going to be negative sign, right? So the moment of this one with respect to this point, it is going to be plus 30, and distance is 3, 4, 5, 6, 7, 8 into 8. Are you okay with this? Okay. Next one, I'll be asking questions maybe for moments about this, for this force and this force with respect to this point. So carefully listen, right? And questions will be coming to point it out, students. It will be not asked to the entire class, right? Okay. So now next one, moment of this one I'll teach, and here I'll be asking you questions, right? So this 40 Newton on rotation with respect to this particular point A, it is going to be anti-clockwise, right? So just give a negative sign. So it is going to be minus, and load value is going to be 40, and distance is going to be from here to here. That is going to be 3, 4, 5, 6, 7. So it is going to be into 7. Are you okay with this? Okay, so now I'll ask you questions. Can you just tell me what will be the moment of this 15 Newton force with respect to this point? Very good. Minus 15 into, excellent, right? Minus 15 into 4, that is going to be correct. And what will be the moment of this force with respect to this point? It's going to be clockwise. Excellent, right? So plus 25 into 2, right? And will this force have any moment with respect to this point? No, right? All of you listen here. There is no perpendicular distance here. The distance factor is going to be equivalent to 0. So this cannot have a moment with respect to this particular point. So this is what is going to be the equation for summation of all the moment of all the forces with respect to this particular point A. Okay with this? Okay, so just make a copy of this. So what is the answer that you get for this? Tell me. Are you getting it as minus 50 Newton meter? Just check whether you're getting this answer. If you got it, very good. Right. And calculator, you'll have to bring it to the class. How many do not have calculator? Why? See, I'll tell you one thing. I want to do the classes in a very, very friendly way. Right? I can't shout at you for not bringing calculators. Rather, I've got better things for you to do. You understand? You expect me to come at the back of your calculator? Then? Okay, so now I'll tell you one thing. This is the last warning I'm just giving for students who are not having calculator, right? And beyond that, how many of you are not carrying the checklist items? Is there anyone without a pencil? Be honest. Raise your hands. I'll check. All the pencils stop. Raise it up. Hey, pencil irka le aunta. Rise it top. And all your calculators, rise it top. All calculators. And then just don't show the covers and all, right? You show that. Turn it the other way, yeah. Open it, open it. I think many are not having calculators here. What happened to your calculator? Okay, see, I'll tell you one thing. This is the last day I'm allowing you inside the class without a calculator. Next class, calculator is a must. So now just have a check. Have you got this answer? Okay, so now all of you listen here. This resultant is an assumption, right? And what will be the moment of the resultant with respect to this point based on this assumption? The moment of the resultant should be equivalent to minus R into capital X. Are you clear with this? So based on Varignon theorem of moments, okay, the summation of moments, that is minus 50, should be equivalent to minus R into X. Do you understand? So what is the value of R? Resultant is going to be equivalent to minus 60. Substitute here and get the value of X also. Have you understood this or not? See, I'll just repeat this again. See, I'm just applying Varignon theorem of moments to get the answer here. And it is very, very simple. Firstly, I'm just calculating the moment of all the forces with respect to this particular point. I'm adding it up, right? So as according to Varignon theorem of moments, summation of moments of all the forces with respect to the point must be equivalent to moment of the resultant, right? So now if you want to get the moment of this particular resultant with respect to this particular point, you assumed it to be anti-clockwise. So based on that, it is going to be equivalent to minus R, and distance is going to be equivalent to X. So I'm just writing it as equivalent to minus R into X, right? So this minus R into X should be equivalent to summation of moment about A. That is what is Varignon theorem of moments, right? So equate this to minus 50, right? And from there you can get the value of X, because R is calculated to be equivalent to minus 60. Is it clear? Get the value of X from there. X is going to be equivalent how much? X is 0.8. It will be 0.8. It will be 50 divided by 60. Check it. 50 divided by 60, it will be 0.83. Please check. Have you got it? Okay, 0.83. X should be equivalent to 0.83 meter. So the distance from here to here, it is going to be equivalent to 0.83 meter. So X is going to be equivalent to 0.83 meter. That is going to be the correct answer. Just have a check. And if you're not getting it, I'll come to your place and explain. Bandad answer, 0.83 meter. And it should be 0.83, and the unit is important. It is going to be in meter. Distance is going to be in meter. And all of you listen here. What will be the unit of moment? Can you just guess? Very good. Newton meter. So now you can write it as a note. I am just giving that statement. Write it as a note. The unit of moment. The unit of moment. The unit of moment is Newton meter. The unit of Newton, sorry, moment is Newton meter. Newton meter. Okay, so with this we'll just get into some other problems. Okay, the next heading you can write it as support reactions. The next heading, support reactions. Support, S-U-P-P-O-R-T, support, sorry. Support reactions. The next heading you can take it as support reactions. The next heading you just make it as support reactions. The next heading you take it as support reactions. And you can just take it as support reactions and okay, firstly I'll just give a note on support reactions and then the different types of beams. Okay, so now you can just write a note. The following are the three different types of supports. The following are the three different types of supports. First one, roller support. The following are the three different types of supports. First one, roller support. First one, it is a roller support. Second one, roller, R-O-L-L-E-R. First one, it is a roller support. And second one, hinged, H-I-N-G-E-D. Second one is a hinged support. And third one, it is a fixed support. And the third one, it is going to be a fixed support. Fixed, F-I-X-E-D. Third one, it is going to be a fixed support. Okay, so now listen here. A roller support is going to be represented by means of a triangle and a circle like this, right? Application of this one I'll tell it to you later. For the time being, you just make a copy of the diagram, right? And a hinge support, it is going to be represented by means of a triangle and a shading like this. Why do you laugh? Any joke is on? Yeah? Okay, and the last one, it is going to be a fixed support. Fixed support is going to be shown by means of a vertical line and a horizontal fixture, right? Just make a copy of that quick. Flies, huh? Flies. Okay, fly, that is disturbing me too, right? And you'll have to you got two hands, right? One you can write, the other one you can hit it also. Are you understanding, all of you? Yeah, sure. Someone said, excuse me here. Who's it? What happened to you? You gone crazy or what? You're not supposed to talk in the class. See, when I'm talking in... What's your name? Soundarya Faith is going to laugh like a crack in my class. Right? And simply throw you out of my class, right? Are you understanding? Okay, I'll repeat this again. All of you listen here. And problems in this, it is very, very simple, right? And you can easily gain 16 marks in just 2 minutes time here. And this basic application is going to be there in the next semester also, right? And in the next semester, for maybe problems involved in this, you'll be given only 2 marks. But this semester, these problems, it will be fetching you 16 marks. So just make it a point that you understand, right? So now, I'll repeat it again. Roller support, it is going to be represented by means of a triangle and a circle, right? And hinge support, second one, it is going to be hinge support, it is going to be represented by means of a triangle and a shading as shown in diagram 2, right? And a fixed support is going to be represented as shown in diagram 3, right? And what are these numbers here? What are the numbers coming to as per your notes? This is 10, okay, we call it as 10A, and this is 10B, and this is 10C. This is 10, okay, maybe, so okay, listen here. The previous diagram, it is going to be 10. Yes, the previous diagram, it is going to be 10, wherein I just showed you the difference between that perpendicular distance and inclined distance, right? So this is going to be under 11 category. So just call this as 11A, and this is going to be 11B, and this is going to be 11C. Just try to have the same numbers, because in case if we need some reference, we can just say it as refer diagram 11A or 11B. I can just give a comment note. Do you understand? So by the end of the semester, this will be like a booklet for you, right? It will be a perfect booklet, which will fetch you at least 75 marks, minimum. Minimum 75, even 90 at times. Okay, so now if you listen here, you can just write a note. A roller support. See, applications of this one, I'll do it in the next class. No time will be there. I'll just give the theory for this in today's class. A roller support. Did you write it as, say, the three different types of supports are? Okay, roller support. Hinged, H-I-N-G-E-D. H-I-N-G-E-D. This is a roller. This is hinged. H-I-N-G-E-D. And this is going to be fixed. The three different types of supports are, first one, roller support, second one, hinged support, and third one, fixed support. So now we can just write a note. The main heading, you can write it as roller support, and below that you can just write, a roller support is represented by means of a triangle. A roller support is represented by means of a triangle. A roller support is represented by means of a triangle and a circle. A roller support is represented by means of a triangle and a circle, as shown in diagram 11A. As shown in diagram 11A. Keep a full stop. And then you can just make a copy of another diagram like this also, wherein maybe two rollers are there and maybe another one also, because in the exams they just make it 2, 3 and on. Don't get confused with these circles. It means the same. Keep a full stop. And then you can just write a note further saying that a roller support a roller support can have a single roller. A roller support have a single roller, as shown in 11A, as shown in diagram 11A. A roller support can have a single roller, as shown in diagram 11A, or it can have more than one roller, or it can even have more than one roller, as shown in 11B and 11. As shown in diagram 11B and 11C. See, here the number of rollers is going to be only one, right? And here it is going to be how many? 2, right? These circles, it is going to represent the roller. And application of this one, I said I'll tell it in the last, right? And here, totally how many rollers are there? It's 3. Do you understand? So in this sketch, only one roller is there. And here you got 2 rollers. And here it is going to be 3, right? Meaning it is same. And the number of reactions which it is going to offer also will be the same. That I'll teach it later. Do you understand? And keep a full stop. And you can just write a note here. A roller support will offer. Which one? 11B, here 2 rollers. No, here there is no roller. Oh, maybe I made this 11B and 11C, no? Okay, so now we can just Okay, 11A dash and A double dash. This will be all right, right? Please make a change. The numbering has gone a little bit wrong. You just call this as 11A dash and this as 11A double dash. Thanks for that, right? Because already this is numbered 11B and 11C. That's fine. A roller support can have two rollers as shown in diagram, say 11A dash, right? Don't make it as 11B because 11B is marked with another diagram, and 11A double dash, right? With that it's clear. Okay, next one, you just write a note below that. Write a note below that. And do you have a chalk piece? Anyone has got a chalk piece or some sort of a ball? Has anyone got a ball or something like that? No. Okay, just do one thing. Get me a pen. Okay, that's all right. It's not, it's no problem, right? Okay, so now just listen here. Say you can just assume this to be a roller support. Do you understand? Say for example, if I'm just going to apply a load like this, listen here, please carefully listen to this. All this, it is going to be of great use the next semester as well as this semester. So now in case if I'm just having this here, and if I'm pressing this one, what happens to this pen? Is it moving? No, right? But if I'm just applying a load in this particular direction, what happens? It is moving, right? Similarly, if I'm just applying a load in this particular direction, what happens to it? And it's going to move, right? So based on this idea, I'll just tell you what a roller support will do. So now roller support, it is going to be basically like a circle like this. Do you understand? So any load coming on to this in this particular direction, it will not move, meaning that there is going to be a reaction in the opposite direction here. Do you understand? But if I'm just going to apply a load like this, it will move off in this direction. And if I'm going to apply a load in this particular direction, it will move off here. Do you understand? So your roller support, always it will be offering only one reaction, right? And that reaction is going to be perpendicular to the plane of rollers. Do you understand? Perpendicular to the plane of rollers in the sense you'll have to understand which is going to be the plane of rollers. So here, this plane is going to be the plane on which the roller is going to rest, right? And this plane is going to be called as the plane of rollers. And similarly here, this it is going to be the plane of rollers. And in the third sketch, this it is going to be the plane of rollers. So that also I'll just give it as a note, right? So you can just make a mark of this one. While doing problems, you will understand this concept even more better. Do you understand? So you can just make a note. A roller support will offer only one reaction. You want this? A roller support will offer only one reaction. A roller support will offer only one reaction. And this reaction, a roller support will offer only one reaction. And this reaction is always perpendicular. And this reaction is always perpendicular to, and this reaction is always perpendicular to the plane of rollers. To the plane, P-L-A-N-E. It is not P-L-A-I-N, it is P-L-A-N-E. To the plane of rollers. Keep a full stop and write a note below that one. Write it as a note, and in that note you can have the plane on which the rollers rest, the plane on which the rollers rest, the plane on which the rollers rest is called as the plane on which the rollers rest. The plane on which the rollers rest is called as the plane of rollers. Is called as the plane of rollers. The plane on which the rollers rest is called as the plane of rollers. See, with this I'll be able to explain it better to the class. Okay, so now listen here. You can assume this to be a roller support, right? This can act as a support. See, and definitely I'm applying a force here, right? And it is supporting the force, right? And if you just see the inner detail of this one, what's exactly happening here is when I'm just giving a pressure or a force here, maybe definitely there is some reaction between my contact surface, right? Between my hand and the bottom surface of this one, right? If no reaction is there, it is going to come down, right? And this reaction should be opposite to that of the load. Can you understand that point? See, this is very much important for your lateral studies. I'm just having this in my hand. And if I'm just going to give a load here, what happens to this is it should go down, right? But at last my hand is going to give a resistive force in the opposite direction to that of the load. That is the reason it is going to stay, right? And if this reaction of my hand is going to be less, what happens here? It comes down. Do you understand? And further, any load like this, it is going to move. And if I'm just applying a load like this, it is simply moving, right? But if I'm just going to apply a load like this, see, I'm pressing it, right? And I'm just applying it maybe bigger, but at last maybe some reaction should be from my hand to the bottom surface of this one, right? So always there will be one reaction for a roller support. If I'm just applying a load like this, there will be one reaction, and that reaction should be perpendicular to the plane of rollers. So you call this load as capital P and the reaction as equivalent to R. And in case If I'm just applying a load like this, then here, that is zero reaction will be here and the roller will roll off. Have you understood this? Okay. Applications of this we'll do it later, right? Maybe just understand the base because application it will take maybe another 1 hour for me to explain. That it will be done in the next class. You understand? Okay. And next one. The next one. You can write the heading as hinged support. The next one you write it as hinged HINGED. The next heading you write it as hinged support. HINGED. Hinged support. And here you can make a note. A hinged support. A hinged support. A hinged support is represented by means of a triangle. A hinged support is represented by means of a triangle. A hinged support is represented by means of a triangle as shown in diagram 11b. A hinged support is represented by means of a triangle. A hinged support is represented by means of a triangle as shown in diagram 11b. As shown in diagram 11b. So now if you listen here, maybe if it is something like this, if I am just having a fold here, maybe that is going to be the best example of a hinge support, right? So if I'm just going to apply a load like this, definitely my fold here, it will not allow this pen to come down. Do you understand? Further, if I'm just applying a load like this also, it is not going to move. Do you understand? Further, if I'm just going to apply a load in this particular direction also, it is not going to move because it is going to be a firm fold, right? So that is going to be the best example of a hinge support. So hinge support, maybe if I'm just applying a load like this, right? It will take up the reaction, right? It will offer one reaction in this particular direction. And did I teach you about resolution of forces? No, I didn't teach you. Okay, so now I'll do one thing. Resolution of forces is going to be important for you to understand this particular concept, right? So we'll just wait for that, right? Maybe I'll just do that first and then come into details of hinge support. Is that all right? Okay. So now you can just get me a note. Okay, now you can just make a note of a hinge support, right? Later on I'll tell you how it really works. Okay, so just make a note of this one. A hinge support offers two reactions. A hinge support offers two reactions. A hinge support offers two reactions. And how it offers two reactions, I'll do it later after teaching resolution of forces. You understand? Okay. So keep a full stop. And the third one, you can just write it as fixed support. The third one, you write it as fixed, F-I-X-E-D, fixed support. The third one, you write it as fixed support. And you can just make a note. A fixed support is as shown in diagram 11C. A fixed support is as shown in diagram 11C. A fixed support is as shown in diagram 11C. Full stop. And you can just write. Fixed supports offer maximum free reactions. 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 Okay, so now I'll just get into this concept of resolution of forces so that we can apply it to supports. Do you understand? Okay. So now you just write the next heading as resolution of forces, resolution of forces, resolution of forces, resolution of forces. The next heading you write as resolution of forces. Okay. I think I just given the note of resultant force. Is it over? Okay. Then did I teach you about say gravitational law of attraction? No. Lame's theorem? Okay. That I'll do it later. Space diagram, free body diagram, all that is there. Okay. So you just write a note on this, and after that I'll give the explanation. The process of the process of the process of the main heading is resolution of forces, RESOLUTION. The main heading you just write as resolution of forces, and below that you can just make a note of this. The process of resolving, or converting a single force, or converting a single force, or converting a single force into two components, into two components, into two components, without changing its effect, without changing its effect, without changing its effect on any body, without changing its effect on any body, without changing its effect on any body, is called as, is called resolution, is called as resolution of a force, is called as resolution of a force. Keep a full stop. Then you can just write, generally the forces are, generally forces are resolved, generally forces are resolved in two mutually perpendicular directions. Generally forces are resolved in two mutually perpendicular directions. Generally forces are resolved in two mutually perpendicular directions. So okay, now listen here. Basically this subject is to be more connected with one subject called as engineering mechanics, right? And this is not important for your exam, but you'll have to know what the subject deals with, right? So engineering mechanics, it is going to deal with statics and dynamics, right? Can you just tell me what statics really is concerned with? In your physics you should have learned. It is going to deal with bodies which are going to be very good, stationary, right? And if it is going to be dynamics, it is going to be mobile, right? But at last, being architects, you're going to deal with bodies which are going to be stationary. Say, for example, this block is not going to move, right? And if it is going to be dynamics, it is going to be important for mechanical engineers, right? That is not going to be into your plate. So you will be mainly focusing on statics. That also you will have to have in mind. So now listen here. This part, what I'm going to tell you now, it is going to be a little bit involved with the dynamics. But at last, just to understand this, I'm giving you this. So need not copy this diagram, but just have an idea of this. So now let me say that there is a body. Let the body be called as equivalent to A. Do you understand? At time t is equivalent to 0. Let us say that it is going to be at this particular point, and let's say that it has moved an inclined distance of say x, and let the time here be equivalent to say some 2 seconds or so. Is it clear? See, this is going to be in connection with say dynamics, because I'm just going to take up a body that is going to move, right? But we'll be more concerned with this only later. Okay, so I'm just saying that there is a body A, and at time t is equivalent to 0, it is going to be here, right? And when time is going to be equivalent to 2 seconds, it has traveled an inclined distance, and that distance is going to be shown as equivalent to small x in this particular diagram. Do you understand? So now listen here. I can just say that the body has traveled an inclined distance like this, or I can just say that it has moved a horizontal distance of this much and a corresponding vertical distance of this much. Both also, it will make the point or the body come to this particular point. Do you agree to that? See, I'll just repeat this for the last time. I am just taking a body, right? The body is named as A, and at time t is equivalent to 0, it is going to be at this particular point, right? And it is going to traverse, or it is going to move an inclined distance of x, and at t is equivalent to 2 seconds, it is going to come to a different point, say, let us call it as A dash. Do you understand? I can just say that the body has moved from this point to this point in an inclined fashion, making an angle theta here. That is one possibility of explaining the motion of this body. Or I can just say that this body has moved a horizontal distance of this much, right, and a corresponding vertical distance of this much, right. If I just move a horizontal distance of this much and a corresponding vertical distance, then again it is going to come to this particular point. Similarly, if a force is there and if it is going to be inclined at an angle, say theta, with respect to the horizontal, this particular force, it will be having a horizontal component and a vertical component, right. So maybe here, if you just want to see the horizontal distant component, it is going to be from here to here. I'll mark it in a different color. The horizontal distance component is going to be here, right? And the vertical distance component is going to be from here to here. These two together, it is going to be something similar to this inclined motion, right? Similarly, if a force is going to be inclined, right, it will be having two components. One is going to be along the x direction. The other one is going to be along the y direction, right? So just make a copy of this one, and after that, I'll explain how to find out the horizontal and vertical components. And after explaining this, I'll just come in touch with the definition and I'll connect the definition with this also. Okay. So just make a copy of the diagram. And what's the time? What time the class? Till 11, I think. Another 10 minutes is there. 11? What's the time now? 11:05. Okay, just make a note of this and then the other things. Okay, just make a copy of this. I'll take the attendance. Start doing break. Okay, do one thing. Just make a copy of the diagram alone. Write details of this. I'll just do it in the next class because that will take minimal half an hour for you to understand, or even more. Okay, so now just get me a pen or blue lead. Blue lead is it? It's a gel, no? Just get a lead pen. Lead pen. Okay, answer your attendance. Ashika. This B, section B. Ajit is here. Yeah, answer your attendance. Yes? Yeah, stop it, stop. The classes, if it is recorded, it is fine. Just have a check whether it's recorded. Answer your attendance, Ajit. Akash, hey, no talking. Akhil is here. Akshaya, Alex, Anusha, Arvind, Dikshit, Deepak, Jilonia, Darshini, Dinesh, Farhan, Gandhi, Jyosha, Induja, Javan, Jay, Karan, Kritika,